unit step function u of t minus a equal to integral, that means u of t minus a equal to 1 for t greater than a, 0 for t less than a. So this is the graph of this function. The another name for unit step function is Heaviside function. Now I am going to find a Laplace transform of this function. L of u of t minus a equal to, by using the definition of Laplace transform, I am going to write 0 to infinity e power minus st u of t minus a dt. But in the interval a to infinity you have a non-zero value. In the interval 0 to a you make it 0. So for that I am going to rewrite this integral as integral a to infinity e power minus st u of t minus a dt. You can substitute the value of u of t minus a in the interval a to infinity. After the integration you may get e power minus st divided by minus s a to infinity. We know that a power minus infinity is equal to 0, approaching 0 as x tends to 0. So I am going to apply that value. From that you may get 0 plus e power minus as divided by s. So e power minus as divided by s as the Laplace transform of unit step function. Depending upon this value a, you have to change the value of the Laplace transform. Next one is impulse function. Impulse, a pulse of a large magnitude, a short duration and a finite strength is called a impulse. So in particular, unit impulse is an impulse of strength 1. This is called a unit impulse function. We can define del t minus a. If t equal to 0, you have to take infinity. For t not equal to 0, the value is 0. And also such that integral over minus infinity to plus infinity del t minus a dt equal to 1. So these are the result I am going to use to find Laplace transform of unit impulse function. So integral over a to b f of t del t minus t naught dt equal to f of t naught. The t naught should be lies between a to b this during this interval. Then only you may get f of t naught. Now by using this formula, if you want to find L of del t minus a, you may get, the formula for a Laplace transform, definition of Laplace transform, integral over 0 to infinity e power minus st del t minus a dt. By using the result, you can write e power minus s a. So this is the answer for e power Laplace transform of unit impulse function. In particularly, suppose if you want to find, if you take a equal to 0, you may get Laplace transform of del t equal to e power minus s into 0, you may get 1. Find L of t into u of t minus 9. It is a unit step function. So here now I am going to apply this property L of f of t minus a into u of t minus a equal to e power minus as into L of f of t. So before applying this property in this problem, try to make all the terms should be in terms of t minus 9. So like this, try to convert. Then only you can apply this property. So for that, now I am going to rewrite t of u in ut minus 9 equal to, I am going to add and subtract 9. So t minus 9 plus 9 u of t minus 9. So you can separate t minus 9 into u of t minus 9 plus 9 u of t minus 9. Now you can take L of t u of t minus 9 equal to, by using linear property you can rewrite L of t minus 9 u of t minus 9 plus 9 into L of u of t minus 9. Now you can apply this property here. If you apply, you may get e power minus 9s L of t only plus 9 into e power minus 9s divided by s, which is equal to e power minus 9s L of t. We know that L of t power n, if n is an integer, means you can use this formula n factorial divided by s power n plus 1 if n is an integer. By using this formula you may get 1 by s square plus 9 e power minus 9s divided by s. So this is the answer for L of t into u of t minus 9. You can rewrite, you can take e power minus 9s divided by s square as a common term. So from that you can get like this. Find L of modulus sin t. So we know that modulus x is nothing but, you can split, you can rewrite this formula as like this. Similarly, in modulus sin t, you can rewrite minus sin t in the interval for negative and sin t for positive. So we must know the period for sin t. The period for sin t is, so the sine curve is coming like this pi to 2 pi, this is pi by 2. So in this case, suppose if you consider one frequency, so in this case pi to 2 pi you have a negative value. So for that, in a particularly in this case, by using this frequency, I am going to rewrite minus sin t if from pi to 2 pi, sin t 0 to pi. So in generally the curve of the graph of sin t is coming like this. Only we are taking t is 0 to infinity while finding Laplace transform. So further you may get like this. it goes lies on. So from that you can decide modulus sin t. So since modulus sin t is a periodic function of period pi, of period pi. So for that, now I am going to apply Laplace transform of periodic function. We know that L of f of t is equal to 1 by 1 minus e power minus ps integral 0 to p e power minus st f of t dt. The period for this function is pi, so you can substitute p equal to pi. So from that you may get 1 by 1 minus e power minus pi s integral over 0 to pi e power minus st. So in the interval 0 to pi the function is sin t. So you can substitute sin t dt by using the integration formula. We know that integral e power ax sin bx dx equal to e power ax divided by a square plus b square a sin bx minus b cos bx. By using this formula you may get 1 by 1 minus e power minus pi s into e power minus st divided by s square plus 1 minus s into sin t minus cos t integral over 0 to pi, which is equal to, if you substitute the limits you may get 1 by 1 minus e power minus pi s. If you apply the upper limit you may get e power minus pi s divided by s square plus 1 into, so sin pi is equal to 0, you may get minus cos pi. In lower limit you have to get e power 0 divided by s square plus 1 into minus cos 0, which is equal to 1 by 1 minus e power minus pi s cos pi s minus 1, so minus of minus plus, so e power minus pi s divided by s square plus 1 plus 1 by s square plus 1, which is equal to 1 by 1 minus e power minus pi s 1 plus e power minus pi s divided by s square plus 1. So 1 by s square plus 1 into 1 plus e power minus pi s divided by 1 minus e power minus pi s. So you can take e power minus pi s by 2 as a common in numerator as well as denominator. So from that you may get e power minus pi s by 2 e power pi s by 2 plus e power minus pi s divided by 2 divided by e power minus pi s divided by 2 e power plus pi s divided by 2 minus e power minus pi s divided by 2. You can cancel this term. So then the remaining term you can apply 1 by s square plus 1 into cot h pi s by 2. So this is the answer for Laplace transform of modulus sin t